In this video you will find the equivalent resistance of this circuit. So we have to find the equivalent resistance between the points A and B. So that is the point A and that is the point B, and all the resistors have the same value, that is R. So let's start. First of all, consider that the potential at the point A is VA and the potential at the point B is VB. So that is VB, and you can see that all these three resistors, that is this one, and this one, have the same value, that is R. So same current will flow through these resistances. So let's consider that this current is I. So this one is also I and this one is also I, and due to this flow of current there must be a potential at the other terminal of the resistors. So consider that the potential at this point is VC. This is due to the current flow through this resistance, that is I. Okay. Similarly, there will be a potential, same VC potential at this point, because same current flow this resistance also, and similarly there is potential VC also. Okay. Now we can see that the potential drop across this resistance, that is this resistance, is VC minus VC, that's equal to 0. Similarly, the potential drop across this resistance is also 0, that is VC minus VC. So now we can short these resistances because there is no potential drop across this resistance. So we can just shorted these resistances are shorted. Now for these shorted resistances, the equivalent circuit will be like, so you have to draw the equivalent circuit, and this time we short the resistances which have no potential drop. So it will be like this. And just like this. And in that place the resistance are shorted, so we short this. Now you can see this circuit is simplified, and this is point VC potential, VC potential, VC potential, and this all this resistance have same value R. Okay. And potential at this point is VA, VB. Okay, that is VA at this point, and potential at this point is VB. Now we can see that the potential drop across all these three resistors is VA minus VC, same value for all these three resistances, and similarly for all these three resistances the potential drop across them is VV minus VC. We take the magnitude only. So we can say that these three resistances are in parallel connection. Similarly, these three resistances are individually in parallel connection. So the equivalent circuit will be like this. These three resistances are in parallel, this 3 1. Okay, all these have value R, is A, and this is the common potential point, that is VC. So we have to draw this common potential point VC, and across them this is the parallel connection of these three resistances. So that is the three resistances in parallel connection. And that this point is B. This is VA and this is VB. Okay, and all of them have the same value R. So R and R. Now we can easily find the equivalent resistance in that case. So first of all, the equivalent resistance of this 3 resistor in parallel connection would be like R by 3, that is R by 3. This calculation is easy, just equivalent resistance 1 by R double prime, that is equal to 1 by R plus 1 by R plus 1 by R, and this is equal to 3 by R. So R double prime is equal to R by 3. Similarly for this point is VC, similarly for this is VA, VBA, and now for these 3 resistance in parallel, the equivalent resistance is also R by 3, and this point is B, R by 3. Okay, now you can see that these 2 resistors are in just in series connection, so the equivalent circuit would be just a sum of this resistance. So this point A, this point is B, and the equivalent resistance is the sum of these two, so that is 1 R by 3 plus R by 3, that is 2 R by 3. Thus we get the equivalent resistance of this circuit, that is 2 R by 3 at the point across the point A and B. In this way you can easily find the equivalent resistance of any circuit. Just see the potential drop across the resistances.